Picture this: a baseball hurtling toward home plate at 105 miles per hour. The average human I can barely track it. The average human brain needs 200 milliseconds just to process what it's seeing. Yet somehow, a batter not only sees the ball, calculates its trajectory, and swings, but makes contact. In that split second, something extraordinary happens. Something that challenges everything we thought we knew about human limitations. But what if I told you there are people among us who operate on an entirely different level? Individuals whose reflexes, speed, and perception of time itself seem to bend the rules of biology. From the ancient battlefields where warriors moved like ghosts through enemy lines, to modern laboratories where scientists are documenting reaction times that shouldn't be possible, we're discovering that some humans are genuinely faster than normal. And the reasons why might be more incredible than any superhero story. The first recorded accounts of superhuman speed date back thousands of years, embedded in cultures across the globe. Ancient Greek texts describe warriors who could dodge spears in mid-flight. Japanese legends tell of samurai who moved so quickly they appeared to be in multiple places at once. Native American folklore speaks of runners who could outpace horses across vast distances. For centuries, we dismissed these as mythological exaggerations. But then came Jesse Owens. At the 1936 Berlin Olympics, Owens didn't just run fast, he moved in a way that seemed to defy physics. Sports scientists studying film footage noticed something peculiar about his gait, his reaction time off the starting blocks, and the way his body seemed to generate power. His 10.3-second 100-meter dash stood as a world record for decades, but it wasn't just the time that amazed researchers. It was how effortless he made it look. Dr. Peter Wyand, a biomechanics expert at Southern Methodist University, spent years analyzing historical footage of exceptional athletes. What he discovered was startling. Certain individuals weren't just training harder or running with better technique. Their bodies were operating under different biological parameters entirely. When we examined the stride mechanics and ground contact times of athletes like Owens and later, sprinters like Bob Hayes and Carl Lewis, we found anomalies that couldn't be explained by training alone, Dr. Wyand noted in his groundbreaking 2010 study. These weren't just fast humans, they were humans whose neuromuscular systems functioned in ways we'd never documented before. But the real breakthrough came in 1988, when sports medicine began using high-speed cameras capable of capturing thousands of frames per second. Researchers could finally see what was happening in those crucial milliseconds when exceptional athletes moved. What they found changed everything we thought we knew about human speed. The discovery was shocking. Some athletes weren't just moving faster, they were perceiving and processing information faster. Their brains were literally operating in a different temporal framework. It was as if they experienced the world in slow motion, giving them superhuman reaction times that allowed their bodies to respond with impossible precision. This wasn't mythology anymore. This was measurable, documented science pointing to something extraordinary about human potential. The scientific revolution in understanding superhuman speed began with a simple question. What makes some people's muscles contract faster than others? The answer led researchers into the fascinating world of muscle fiber composition and neurological processing speeds. Dr. Michael Johnson, the legendary 400-meter world record holder, volunteered for extensive testing at the University of Texas Sports Medicine Center. The results were unprecedented. Muscle biopsies revealed that Johnson possessed an extraordinary ratio of type I9 muscle fibers, the fastest contracting muscle fibers in the human body. While average humans have about 25% type I9 fibers, Johnson's legs contain nearly 80%. But muscle composition was only part of the equation. When researchers measured Johnson's reaction times using electroencephalography, EEG, they discovered something even more remarkable. His brain-to-muscle signal transmission occurred 40% faster than average humans. The electrical impulses traveling from his brain to his leg muscles moved at speeds that bordered on the superhuman. Dr. Elena Breslin, a neurophysiologist at Stanford Medical Center, has spent the last 15 years studying what she calls temporal perception anomalies in exceptional athletes. Her research reveals that some individuals literally experience time differently. We've documented cases where athletes report that during peak performance, the world appears to slow down dramatically, Dr. Breslin explains. They describe seeing individual droplets of sweat falling, hearing the distinct sound of their heartbeat, and having what feels like minutes to make split-second decisions. When we measure their neural activity during these moments, we see brain wave patterns that are completely outside normal parameters. Perhaps the most compelling evidence comes from a classified military study conducted in 2018. Special Forces operatives underwent extensive testing to understand why certain individuals demonstrated reaction times and movement speeds that seemed impossible. The results, partially declassified in 2022, revealed that approximately 0.3% of the tested population exhibited neurological processing speeds that were 200 to 400% faster than average. One subject, identified only as Operator X, demonstrated the ability to draw and fire a sidearm in 0.12 seconds, faster than the human eye can track. High-speed cameras revealed that his movements were so fluid and precisely coordinated that they appeared almost mechanical in their perfection. But the most startling discovery came from brain imaging studies. These exceptional individuals showed unusual activity in the cerebellum and basal ganglia, brain regions associated with movement coordination and time perception. It was as if their brains had developed enhanced processing capabilities that allowed them to operate in an accelerated temporal framework. The implications were staggering. These weren't just people with good reflexes. These were humans whose neurological systems had somehow evolved beyond normal limitations. As research progressed, scientists began encountering phenomena that pushed the boundaries of accepted biological science. The discovery of genetic mutations that seemed to confer superhuman speed opened up entirely new fields of study and raised profound questions about human evolution. In 2019, Dr. Maria Santos at the Institute for Advanced Genetics made a breakthrough discovery while studying the DNA of elite athletes. She identified a rare genetic variant, dubbed the ACTN3X mutation, present in less than 0.01% of the population. Individuals carrying this mutation showed dramatically enhanced fast-twitch muscle development and, most remarkably, accelerated neural processing speeds. What we're seeing is essentially a genetic lottery ticket for superhuman performance, Dr. Santos explains. People with this mutation don't just train to become fast, they're biologically predisposed to operate at speeds that seem impossible for normal humans. But genetics alone couldn't explain all the cases researchers were documenting. Enter Dr. James Mitchell, a neurologist at Johns Hopkins, whose work on temporal lobe abnormalities revealed something extraordinary. Dr. Mitchell has been studying individuals with a rare condition he terms temporal acceleration syndrome, TAS. Patients with TAS report that during moments of extreme stress or focus, time appears to slow down dramatically. Unlike the subjective slow motion experience many people report during emergencies, TAS patients demonstrate measurable changes in their perception and reaction capabilities. One patient, a 28-year-old emergency room nurse, described being able to see individual raindrops falling during a car accident, Dr. Mitchell recounts. When we tested her reaction times under stress, she demonstrated the ability to process and respond to visual stimuli 600% faster than normal. Her brain scans showed unusual activity in regions associated with time perception that we've never documented before. The most controversial research comes from the classified Project Quicksilver, a joint study between the Department of Defense and several major universities. According to leaked documents, researchers were investigating reports of military personnel demonstrating impossible feats of speed and reaction time in combat situations. One documented case involved a Marine who reportedly dodged sniper fire by seeing the muzzle flash and moving before the bullet arrived. While this sounds like fiction, high-speed cameras and ballistics analysis suggested that the Marine's reaction time was indeed fast enough to begin evasive movement before the bullet reached his position. The scientific establishment remains divided on these findings. Traditional biology suggests that human neural transmission speeds have fixed limitations. But the mounting evidence of individuals operating beyond these limitations is forcing researchers to reconsider fundamental assumptions about human potential. Dr. Patricia Wong, a biophysicist at MIT, offers a provocative theory. What if we're not seeing anomalies or mutations, but glimpses of human evolution in action? What if some individuals are developing enhanced neurological capabilities that represent the next step in human development? The question remains, are these rare individuals genetic outliers, or are they harbingers of humanity's future? Recent advances in neuroscience and quantum biology are revealing possibilities that blur the line between science and science fiction. The discovery that consciousness might operate on quantum mechanical principles has opened up entirely new ways of understanding superhuman speed and perception. Dr. Roger Penrose, the Nobel Prize-winning physicist, has proposed that human consciousness involves quantum processes in the brain's microtubules. Building on this theory, researchers are now investigating whether exceptional individuals might have enhanced quantum coherence in their neural networks, allowing for faster-than-normal information processing. At the University of California, Santa Barbara, Dr. Lisa Chen's quantum biology lab has made remarkable discoveries about how some brains might operate. Using advanced scanning techniques, her team has identified individuals whose neural networks show unusual quantum coherence patterns during moments of peak performance. What we're seeing challenges our understanding of how consciousness and physical reality interact, Dr. Chen explains. These individuals appear to be accessing information processing capabilities that operate partially outside classical physics. It's as if their brains can tap into quantum mechanical properties to achieve superhuman performance. Perhaps the most extraordinary case comes from Dr. David Hoffman, a cognitive neuroscientist at Princeton. He's been studying Sarah Martinez, a 31-year-old martial artist who demonstrates abilities that seem to defy explanation. During controlled tests, Martinez has shown the ability to react to visual stimuli before they appear on screen, a phenomenon that should be impossible according to our understanding of causality. Sarah consistently begins her response to visual cues 50 to 100 milliseconds before the stimulus appears, Dr. Hoffman reports. We've repeated these tests hundreds of times under controlled conditions. The results suggest that her brain is somehow accessing information about future events, possibly through quantum mechanical processes we don't yet understand. The implications are staggering. If consciousness can indeed operate through quantum mechanisms, it might explain how some individuals achieve seemingly impossible feats of speed and perception. They might not just be moving faster. They might be operating with a form of precognition that allows them to anticipate and respond to events before they fully manifest in classical reality. Military applications of this research have attracted significant attention. The Defense Advanced Research Projects Agency, DARPA, has reportedly invested over $200 million in understanding and potentially enhancing these capabilities. The goal: creating soldiers who can operate with superhuman speed and awareness on the battlefield. But the research raises profound ethical questions. If we can understand the mechanisms behind superhuman speed, should we enhance humans to possess these abilities? And what are the long-term consequences of pushing human biology beyond its natural limitations? Dr. Elizabeth Warren, a bioethicist at Harvard Medical School, warns, "We're approaching capabilities that could fundamentally alter what it means to be human. The ability to perceive and react at superhuman speeds might seem beneficial, but we have no idea what the psychological or social consequences might be. Are we creating a new species, or are we simply unleashing potential that was always within us?" The answers to these questions may determine not just the future of human enhancement, but the future of humanity itself. As we stand at the threshold of understanding superhuman speed, we face choices that will define the next chapter of human evolution. The scientific evidence is clear. Some individuals possess capabilities that transcend normal biological limitations. The question now is what we do with this knowledge. Current research suggests that superhuman speed might be achievable through three primary pathways: genetic enhancement, neural modification, and consciousness training. Each approach offers extraordinary possibilities and equally extraordinary risks. Genetic therapy shows the most immediate promise. Dr. Santos's team has successfully introduced the ACTN3 X mutation into laboratory subjects, resulting in dramatic improvements in muscle fiber composition and neural processing speeds. Early human trials, conducted under strict ethical oversight, have shown that genetic modifications can enhance reaction times by 300 to 400% with minimal side effects. We're essentially giving people access to capabilities that evolution provided to only a tiny fraction of the population, Dr. Santos explains. Within 10 years, we might be able to offer genetic therapies that grant superhuman speed to anyone who wants it. Neural enhancement represents a more controversial approach. Experimental brain implants that stimulate the cerebellum and temporal cortex have shown remarkable results in enhancing processing speeds and time perception. Test subjects report experiencing the world in slow motion while maintaining normal movement capabilities, effectively granting them superhuman reaction times. But perhaps the most intriguing possibility involves consciousness training. Drawing from quantum biology research, scientists are developing meditation and training techniques that appear to enhance quantum coherence in the brain. Preliminary results suggest that with proper training, individuals might be able to access superhuman perception and reaction capabilities without any physical modifications. The military applications are already being explored. Special Forces units are reportedly training with quantum consciousness techniques, showing dramatic improvements in combat performance. Intelligence reports suggest that other nations are pursuing similar programs, raising concerns about a superhuman arms race. However, the implications extend far beyond military applications. Enhanced humans with superhuman speed could revolutionize emergency response, medical procedures, and countless other fields. Surgeons with enhanced reaction times could perform operations with unprecedented precision. Emergency responders could save lives in situations where split-second reactions make the difference between life and death. But we must also consider the potential dangers. A society divided between enhanced and unenhanced humans could face unprecedented social tensions. The psychological effects of experiencing the world at superhuman speeds remain largely unknown, and the long-term biological consequences of pushing human capabilities beyond their evolved limits could be catastrophic. Dr. Wong offers a sobering perspective. We're not just talking about making people faster. We're potentially creating a new form of consciousness, a new way of experiencing reality. The enhanced individuals we're studying report feeling increasingly isolated from normal humans. They describe normal people as moving and thinking in slow motion. We might be creating a species that can no longer fully connect with baseline humanity. The ethical frameworks for human enhancement are still being developed. Questions about access, equity, and consent remain largely unresolved. Should superhuman speed be available to everyone, or will it become another form of inequality? How do we protect the rights of both enhanced and unenhanced humans? And perhaps most importantly, at what point do enhanced humans stop being human at all? As research continues and technology advances, these questions become increasingly urgent. The power to transcend human limitations is within our grasp. Whether we use it wisely may determine the future of our species. The age of superhuman speed is approaching. The only question is whether humanity is ready for what comes next. The journey from ancient legends to cutting-edge science reveals a profound truth. The boundaries of human potential are far more flexible than we ever imagined. Some people truly are faster than normal, not through training or luck, but through genetic gifts, neurological anomalies, and possibly quantum mechanical processes we're only beginning to understand. As we unlock these secrets, we're not just discovering how to make humans faster. We're uncovering the next chapter in human evolution. The question isn't whether superhuman speed is possible. The evidence proves it is. The question is what we'll do with this knowledge, and whether we're prepared for a world where the impossible becomes everyday reality. The future is approaching faster than we ever thought possible. And soon, we might all be fast enough to keep up with it.